Hello everyone. In this video we will learn about finding the distance of a point from a line that may be perpendicular distance or it may be in a given direction. Also we will find out the distance between a pair of parallel straight lines. See, first we go for finding the perpendicular distance of a point from a line. Suppose P is the point whose coordinates are x1, y1 and a line is given to us, that is ax plus by plus c equal to 0. If we draw a perpendicular from P to this line, that is PM, we are to find out this distance. This is suppose D. What to do? First we will see the points of intersection of the line on the axis, that is A and B. Join PA and PB to form a triangle PAB. Then what we will do? We will find the area of this triangle by using the vertices. And also we know that the area of a triangle is half into base into altitude. Then we will find the area of the same triangle by using that particular formula. And then we can find out the distance D by equating those two areas. For the point of intersection, we can see the points of intersection of line 1 on the axis are A, that is minus C upon A, comma 0, and B, that is 0, comma minus C upon B. This we have already learned how to find out when we transform this particular line in the intercept form. Now we have the vertices of this particular triangle, that is P x1 y1, A minus C upon A 0 and B, that is 0 comma minus C upon B. We can find out the area of the triangle. So we can write area of triangle PAB equal to, applying the formula, that is half into x1 y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Applying the values, we are getting here half x1 is x1, y2 is 0, minus y3 is minus c upon b, plus x2 is minus c upon a, y3 is minus c upon b, minus y1, and y1 is y1, plus x3 is here 0 into y1 minus y2 is 0. Simplifying this, we are getting half into c upon b into x1 plus c square upon ab plus c upon a into y1 and plus 0. If we take the LCM as AB and C as common, will we get half into C upon AB, and here it will be AX1 plus C plus BY1. We can also write this as 1 upon 2 into C upon AB into AX1 plus BY1 plus C. Now we will find out the area of the same triangle by applying the formula half into base into altitude. Here base is AB. So first we will find out the length of AB, and that we can find by applying the Pythagoras theorem. Since OA is C upon A and OB is C upon B, the length of AB will be root of C upon A square plus C upon B square. This is equal to root of C square upon A square plus C square upon B square. If we take A square into B square LCM and C square is common, this will be C upon AB into root of B square plus A square, or not? And now we can find out the area of the triangle PAB. Area of triangle PAB equal to half into base, that is AB, into height, that is PM, that is altitude. This is equal to half into C upon AB into root of A square plus B square into PM. PM is D. If we compare these two areas, the first area we have obtained here, second area we have obtained here, what we get? If we write this as area of triangle PAB, that is 1, and this we write as 2, what we get from 1 and 2? From 1 and 2. We get, comparing the areas, that half of C upon AB into AX1 plus BY1 plus C is equal to half into C upon AB into root of A square plus B square into D. 2 and 2 cancel here. C upon AB cancels C upon AB. From this we get the value of D as AX1 plus BY1 plus C upon root of A square plus B square. Since this is the square root of A square plus B square, we will make use of the modulus sign, since we say that the perpendicular distance is to be taken as positive. We can also remember this formula as L1 upon root of A square plus B square. What is L1? We know this part, left hand side of the line is written by L. If we substitute the coordinates of x1, y1 in this particular part, that is left hand side, then we say L1 is equal to AX1 plus BY1 plus C. So it's easy to remember the distance formula of a point from a line, that it is modulus of L1 upon root of square of coefficient of x plus square of coefficient of y. Now we will learn how to find out the distance between a pair of parallel lines. Suppose we are given two parallel lines. One is AX plus BY plus C1 equal to 0 and another is AX plus BY plus C2 equal to 0. We are finding the coefficients of x and y are equal. So the lines are parallel to each other. Suppose we want to find out the distance between them, and this distance is suppose D. We will draw a perpendicular from the origin O, that will be certainly the perpendicular for both the lines. OM is the perpendicular to this line number 2 and OL is the perpendicular to line 1. If we consider that OL is equal to D1 and OM is equal to D2, can we say then D is equal to D1 minus D2? We know how to find out the distance of a point from the line. So we can say here D1 in this case, the distance for line 1 from the origin. According to that formula which we have learned just now, D is equal to AX1 plus BY1 plus C upon root of A square plus B square. If point is origin x1 y1, that is equal to 0 comma 0, can we say then D will be equal to A into 0 plus B into 0 plus C upon root of A square plus B square, and that is equal to C upon root of A square plus B square. We have also learnt this, how to find out the distance of a line from the origin in the normal form or perpendicular form of the line, if you remember. If we apply this particular formula for D1, do we get here this is C1 upon root of A square plus B square? And D2, distance from the origin to this line number 2, will that be C2 upon root of A square plus B square? So the distance between the parallel lines will be that is d is equal to d1 minus d2, and that is c1 upon root of a square plus b square minus c2 upon root of a square plus b square. We get here modulus of c1 minus c2 upon root of a square plus b square. So this becomes the formula to find the distance between two parallel lines. But please remember, we have to see that the coefficients of x and coefficients of y in both the equations are to be equal. If they are not equal, we have to make them equal. For the applications of the concept which we have learnt just now in this video, we will discuss some of the examples, and the first one here is find the perpendicular distance of point 2, 3 from the line 3x plus 4y plus 7 equal to 0. See, here we have got the point that is 2, 3, that is x1, y1. The line here is 3x plus 4y plus 7 equal to 0. We find a is 3, b is 4 and c is 7. We know how to find that. And hence, the distance of the point from the line can be found out by the formula, that is d equal to ax1 plus by1 plus c upon root of a square plus b square. Substituting the values, we get here a means 3, x1 means 2, b means 4, y1 means 3 plus 7, that is c upon root of a square plus b square. That is here 6 plus 12 plus 7 upon root of 9 plus 16. We know it is 25 upon 5 because root of 25 is 5. This comes as 5 units. So the distance of a point we can find out by applying the formula in this particular manner. The second example we discuss is based on finding the distance between a pair of parallel lines. Here the lines have been given to us and we have to find out the distance between them. We will write the equations of the lines. We write the lines which are given to us are 2x plus 3y plus 4 equal to 0. This is the first one. And the second is 4x plus 6y minus 3 equal to 0. This is the second one. We find here a1 upon a2 is 2 upon 4, that is 1 by 2. And b1 upon b2 is 3 upon 6, that is also 1 by 2. Whereas c1 upon c2 is 4 upon minus 3. So we find here a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Therefore, the lines are parallel. To find out the distance, as I have discussed just now while going for the concept, that we have to keep the constants, that is the coefficients of x and coefficients of y in both the equations equal. Here we find this is 2 and 3 and here it is 4 and 6. So either we multiply this equation by 2 or we divide this equation by 2 so that the coefficients become equal. Suppose we multiply this by 2. Multiplying equation number 1 by 2. We are getting 4x plus 6y plus 8 equal to 0. From this what we are finding? A is equal to 4, B is 6, C1 is 8 and C2 is equal to minus 3. Applying the formula for the distance between the parallel lines, we find the distance between the parallel lines. We know is given by d equal to c1 minus c2 upon root of a square plus b square. If we apply the values here, this is 8 minus 3 upon root of 4 square plus 6 square, which is equal to 8 plus 3 upon root of 16 plus 36. This is equal to 11 upon root of 52. We can also write this as 11 upon 2 root 13 units. So this is the way we can find out the distance between a pair of parallel lines. The third example, we are discussing about a problem where we are not finding the distance of the point from the line perpendicular. That is to be parallel to a given line. Like here it is given, find the distance of the point 3, 5 from the line x plus 3y minus 5 equal to 0 measured parallel to the line 3x minus 4y plus 2 equal to 0. To understand the concept, what we do, we draw the lines here. This is line 1, this is line 2, and this is the point P, 3, 5. We have to find out the distance of line 1 from P, that is parallel to this line. So we draw a line PM parallel to line 2 from point P. It means we have to find out this distance PM. Suppose this is D. So what we will do? We will find out the equation of this line PM and then find the point of intersection of PM and line 1, that is M. After finding the coordinates of M, we can make use of the distance formula to find out PM. So what we do here, we are writing the line which is given to us is x plus 3y minus 5 equal to 0. The point which is given to us, that is P, is 3, 5. And the another line which is given to us is 3x minus 4y plus 2 equal to 0. So we find a line parallel to this. A line parallel to 2 is 3x minus 4y equal to k. The coefficients of x and y are to be kept same, only the constant will change. And we can find out the value of this constant by substituting the point 3, 5 in it. So for 3, 5, we are getting 3 into 3 minus 4 into 5 equal to k. It means k we are getting 9 minus 20, that is minus 11. Therefore, the equation of line PM is 3x minus 4y equal to minus 11. For the point of intersection M, for M, solve the equations 1 and 3. After solving, what we are getting is, we are getting x equal to minus 1 and y equal to 2. Therefore, point M is minus 1, 2. And then we can find out the distance. Therefore, distance PM, that is equal to D. We can make use of the distance formula, that is root of x1 minus x2 square plus y1 minus y2 square. Substituting the values, we get here root of 3 minus 1 square plus 5 minus 2 square, that is root of 4 square plus 3 square, which is equal to 5 units. So by this example, we have understood how to find out the distance of a point from a line measured parallel to a given line. In the next video, we will learn about the transformation of the axis, or we can say shifting the origin. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.